Section 7.2 on two variable linear systems. So all of the systems that we're looking at in this section are linear. So there's three different situations that we can come into when we're solving these systems. So first, we could get an x equals some number and a y equals some number, which means that there's one solution and that those two lines intersect at one point. That would also mean that the slope of those two lines is different. The second situation is whenever you're solving, you could turn into a number equals itself. 5 equals 5, 3 equals 3. That would mean that there are infinite solutions to that system of equations. What actually means is the two lines are the same line, so it's graphing on top of itself, so every point is a solution, and the slopes would be equal in that case. The last situation is when you're solving and you get that a number equals a different number. 5 equals 3. So 5 doesn't equal 3, so that means that there are no solutions to the system. That actually means that the two lines are parallel to each other and they never intersect, and the slopes of parallel lines are also equal. In this section, we're going to be solving these systems using the elimination method. And the object of the elimination method is to get one of the variables to cancel out and then solve the system with one variable by substituting back into the original equation. So sometimes we have to do a little bit of algebra to be able to get those variables to cancel out. So example 1 says to solve the system using elimination. So I have x plus y equals 0 and 3x plus 2y equals 1. So automatically when I look at these two equations, nothing is going to cancel when I try to add these equations together. The x's are both positive, the y's are both positive, and they're different numbers, so nothing's going to go away. So I need to multiply something times one of the equations to get one of the variables to cancel. It doesn't matter which variable you choose. Sometimes it's easier with x, sometimes easier with y, or it makes no difference. So what I'm going to do is I'm going to multiply the top equation by -2. And in doing that, that's going to make it where the y's will wind up canceling because I'll have a -2y and a positive 2y. And they'll cancel out. So when I multiply -2 times the top equation, I'm going to get -2x minus 2y equals 0. -2 gets multiplied times everything in the equation. The second equation is going to stay the same. I don't need to multiply anything times it, so I'm just going to rewrite it. Now I'm going to add the two equations together. So if I have -2x plus 3x, that's going to give me 1x. And you see that the y's would cancel, and 0 plus 1 equals 1. So x equals 1. Well, now that I know what x equals, I can plug back into one of the original equations to find out what y equals. So I'm going to take x equals 1 and I'm going to substitute it in the x for the very first equation. So that's going to give me 1 plus y equals 0. So then when I solve for y, I get y equals -1. So my solution to the system is 1, -1. If I graph these two lines, they would intersect at the point 1, -1. Okay, in example 2, I have x minus y equals 2 and -2x plus 2y equals 5. So again, I'm trying to look at the two variables and decide which one I want to cancel out and what I can multiply by one of the equations to get that variable to cancel. So what I'm going to do is I'm going to try to get the x's to cancel. So I want to multiply the top equation by 2. Then I would have a positive 2x and a negative 2x, which will cancel out. So when I multiply 2 times x minus y equals 2, I get 2x minus 2y equals 4. I rewrote the second equation exactly as it is because I'm not doing anything different to that equation. And now I'm going to add these two together. And you notice that the x's are going to cancel and the y's are going to cancel. So that's going to leave me with 0 equals 9. And we know that 0 does not equal 9. So when you get a number equals a different number, that means there is no solution to the system. That would mean that these lines are parallel to each other and they never intersect. So in example 3, we have 3x minus 2y equals 5, and negative 6x plus 4y equals negative 10. So again, decide which variable you want to cancel. It can be x's or y's. I'm going to get the x's to cancel. So I'm going to multiply the top equation by 2 to get the x's to cancel. So everything in the top equation times 2 will give me 6x minus 4y equals 10. I'm going to rewrite the second equation exactly as it is. And you notice this time that the x's cancel, the y's cancel, so that gives me 0 on the left. And then the 10's cancel, which gives me 0 on the right. So 0 equals 0 is a true statement, so that means that there are infinite solutions to this system of equations. If I graph these two lines, it would be the same line on top of itself, so it meets at every point. Okay, in example 4, this time I'm not seeing anything that jumps out at me on, oh, I should cancel the x's, or oh, I should cancel the y's, because everything's positive here. It's not as obvious. And on this one, I may have to multiply something times both equations to be able to get the x's or the y's to cancel. So what I think I should do is multiply the top equation by negative 3 and the bottom equation by 5. Notice in doing this, this will make the x's cancel out. I would have a negative 15x on the top and a positive 15x on the bottom. So let's multiply negative 3 times the top equation. That's going to give me negative 15x minus 18y equals negative 72. Now I'm going to multiply 5 times the bottom equation, which will give me 15x plus 25y equals 90. So now I'm going to add the two equations together, and the x's should cancel out here because that's what I wanted to do from the start. So the x's are gone. Negative 18 plus 25y is going to give me 7y, and then negative 72 plus 90 will give me 18. So then I need to divide by 7 on both sides to get y by itself. So y is going to equal 18 over 7. So now I need to take what y equals and substitute it back into either one of the top equations. It doesn't matter which one. So I'm going to plug in 18 over 7 into the top equation, which is going to give me 5x plus 6 times 18 over 7 equals 24. I need to get x by itself. So this is going to be 5x plus 108 over 7 equals 24. Now don't let the fractions scare you. We're going to let our calculator do the work. So we know we need to subtract 108 over 7 from 24. So just type that into your calculator. 24 minus 108 over 7, and then change it back to a fraction. Hit Math, enter, enter. When you do that, you should get 5x will then equal 60 over 7. So now we need to divide by 5 on both sides. So we're going to put 60 over 7 in parentheses, and then we're going to divide by 5. And then change it back to a fraction by hitting Math, enter, enter. So then x turns out to be 12 over 7. So our ordered pair for this system is 12 over 7, 18 over 7. Remember, whenever you get your answers, always put them in the ordered pair x, y. Sometimes we solve for the x first, sometimes for the y. It doesn't matter which order, but when you write the solution, make sure it's x, y. Okay, so in example 5, this one looks a little scary just because we've got these weird looking decimals here. Well, you can always change an equation. If you multiply something times everything in the equation, then it's okay. It's the same equation technically. So what I'm going to do is, you can think of it two ways. That I can multiply everything in the equation by 100, or just move the decimal over 2 places for every number. So when I do that, that's going to give me 5x minus 3y equals 21. The second equation will be 7x plus 2y equals 16. So this looks a little less scary just because it doesn't have the decimals, but it means the same thing. These are equivalent equations. So now I need to decide what variable I want to cancel. Since the y's already have one positive and one negative, let's try to get the y's to cancel. So I'm going to multiply the top equation by 2 and the bottom equation by 3. In doing this, I will get a negative 6y in the top equation and a positive 6y in the bottom. So the top equation times 2 is 10x minus 6y equals 42. The second equation, I'm going to multiply everything times 3. So that's going to give me 21x plus 6y equals 48. So when I add these equations, I'm going to get 31x, the y's are going to cancel, equals 90. I divide by 31, and x equals 90 over 31. So I want to plug x back into one of the equations. I can pick any one of the equations that I have listed here. They are all equivalent equations. I'm going to go to the easiest one. I'm not going to pick the decimals at the top. I'm going to plug into one of the second equations. So I'm going to plug into the green equation and multiply 5 times 90 over 31 minus 3y equals 21. So 5 times 90 over 31 is 450 over 31. Again, don't be afraid by the fractions. Let your calculator do the work. We're going to subtract 450 over 31 from 21 and then change it back to a fraction. So that will mean that negative 3y will equal 201 over 31. And then I divide by negative 3. So then y equals negative 67 over 31. So my solution to this system is the ordered pair 90 over 31, comma, negative 67 over 31.